Okay, let's go. Okay, ladies and gentlemen, welcome to another week of EECS 498. Congratulations to those of you who have submitted homework 5. Well done. That is not an easy assignment, is it? But I will say it's not nearly as hard as it was last year when in order to get through, you had to get all the off by 1 pixel errors corrected, okay? Now, what's up?
Can I guess that one random tile that was pure pink, was that just literally the entire tile being off by 1?
I'm not entirely sure what is causing that. So I looked at some student code bases who are having off by 1 pixel errors. I cloned them down. I spent half a day working through it myself and saying, okay, what's the differences here? What's the problem? And when I decided that this was just a horrible waste of time for myself and for students, I decided, okay, it's time to break glass in case of emergency and just go to similarity scores. And it only took me about 45 minutes to get that implemented into the autograder, which is a suggestion that maybe my code base for the autograder isn't as bad as I thought it was. And to my surprise, it was it wasn't really. So the big issue with similarity scores, and the reason I've been so hesitant to try it, is that when you move to similarity scores, it allows smaller test cases where you implement a feature that doesn't affect the frames very much. It's possible that those cases could get bulldozed, right? Like you can just ignore the feature, you still get a very high similarity score, and you pass. Now, I could introduce unique thresholds on a per test case basis to try and fight that, but other problems remain. So if you do that kind of thing, oops, a student has off by 1 pixel errors in other places, and now they don't pass. Another issue with similarity scores is that they can allow you to ignore problems on early test cases, and then during later, larger test cases, you've got many different problems causing many pixels to be off, and that causes things to build up, and now you're failing a test case, and you have no idea what to go back and fix, right? So that's a concern as well. Not on homework 5, but homework 6 is going to be the real challenge of this new approach. Homework 7 and homework 8 were not too bad, even with the off by 1 pixel issues. There were just simply not that many. One really interesting thing that's going to happen soon is that most of your gameplay-related C++ logic will be moving into the world of Lua, where I control it, okay? Right? The only Lua that will ever run in your engine is the Lua that I write for your test cases. Now, you can write some of your own to play around with it if you want to learn Lua. You'll want to do that for the final exam, but this basically eliminates most of the possibilities for off by 1 errors. Yes?
Okay, I'm not sure how hard this will be, but for some of the future test cases, is it possible that if you don't get 100% on the similarity score, even if it's passes, could we still see
the footage?
Yeah, at least just see what your friends are. So
yeah. Yeah, that wouldn't be super hard, I don't think. Yeah, and I thought about that. They might want that in the future. Maybe I'll add it. We'll see. Yes?
If we only passed a bunch of test cases because of the similarity scores, would you recommend investing any time into trying to figure those out?
No, not really. Like if it's something egregious, my character is just facing the wrong way, but because the character is kind of symmetric, right, it kind of worked out. Then you want to probably go back and figure it out. Yeah, I'm gonna be closely watching how homework 6 goes as people progress through it. We're gonna be tweaking all of this quite a bit as we go. So anyway, well done to all of you. These are not easy assignments at all, and your break is coming up. Your first big kind of little period of rest begins now with homework 6. So this is a 2-week-long assignment. It is 2 weeks long because it was so challenging last year. This year, you've got a lot of things in your corner. You've got the autograder helping you out a lot more. It's being much nicer about off by 1 pixel issues. So I suspect that some of you will kind of fly through this a bit faster than you think. But we're going to talk about homework 6 and some of the unique challenges that it brings. One cool thing, and I want you to count with me, okay? Can you count? Test suite 0, test suite 1, test suite 2. We've got 3, 4, 5, and 6. And that is it. Only 6 test suites. Oh my gosh, this has got to be the easiest one yet. All right. Okay, so let's go ahead and get to it. We are right at the beginning of Continuous Worlds. Our main objective today is going to give you to be kind of walk you through a little bit of that, and then to introduce you to a really powerful concept from Unity, actually, the input manager. I'm going to show you how to implement your own Unity-style input manager with basically the exact same API, except now you are writing the C++ that makes all that come to life, okay? And that's going to give you a good start on homework 6, where you're going to want to be checking inputs much more often, and you're going to want a much more sophisticated way to check inputs, okay? If you do make a good input manager, it'll also make homework 7 quite a bit easier, because the input manager that you make, well, in C++, you make it, you're going to have to provide those same APIs to Lua, okay, so that your users of your engine can enjoy that wonderful interface as well, all right? Okay, so let's go ahead and look at what we got for today. We do have a cool engine, a very impactful engine, particularly on PC. This is the famous Source engine, okay? It is a AAA game engine from the creators of Steam. Valve Corporation, they used to do a lot more interesting things than just run a digital store. They still do some interesting things today, but if you've ever heard of Dutch disease, has anyone ever heard of that? Basically, it's this fairly well-known kind of international phenomena where a country discovers an extremely valuable raw resource like oil. They become addicted to its extraction. Everything in the state becomes focused on just cultivating it, and thus the entire state begins to kind of wither and fall apart, despite having bountiful riches under its soil. And this is kind of sort of something that happened to Valve, right? So as soon as they struck gold with Steam, suddenly they could make dramatically more money just through running a digital storefront than they could making games. And those muscles, those game-making muscles, kind of sort of started to wither a bit. They have started coming back. They've done some really interesting hardware stuff with Steam Deck. I wonder what inspired that one. And they also have interesting VR stuff. They have the occasional title like Half-Life Alyx that comes out and is still well-received, but their output simply isn't the same. Source Engine was initially released in 2004. It was created by Valve Corporation. One cool thing is that I believe this is open source software. I do not think it is MIT, is it? Yeah, it's the Source 1 SDK license. I have no idea what this entails. It is not a standard license, so you'll have to read through it, possibly even with a lawyer, to figure out what it means. It doesn't look super long, though. But you can get access to this source software and the code. You can mess with it. You can even build some tools, I think. This engine is absolutely famous for the game Half-Life 2, which is an important part of Steam's initial success, okay? When Steam came out, people didn't like it. People didn't want to use it, okay? It didn't have much to sell, but there was one reason they tolerated it. Does anyone know what that reason is? If you wanted to play Half-Life 2, one of the most impressive shooters of the early 2000s, a game that in many ways felt about a decade ahead of its time, if you wanted to play that game, what did you need to install and use? You need to install and use Steam, okay? Right? And Steam was kind of Valve Corporation's launcher for their titles. If you wanted to launch and play a Valve-made game, whether it was Counter-Strike or whether it was Half-Life or Half-Life 2 or Team Fortress, you had to use their launcher. You simply had to. There was no other choice. Does anyone else know of any other launchers that are similar? They function in a similar way today? Epic, right? You want to play Fortnite? What do you got to get? You got to get the Epic Game Store, okay?
Good old games.
Good old games, GOG, right? Good old games Galaxy. They have their own launcher. You want to buy and play one of those classic titles, you got to get that launcher. Yes?
EA or Origin? I can't remember.
Yep. Yeah, EA had something called Origin that they've since shuttered, okay? Our favorite company, Ubisoft, what do they have? Uplay, absolutely, Uplay, okay? And sometimes that works and lets you play the games. So what else? Bethesda has their own launcher.
What is it? Red
CDPR has a launcher.
Okay, CDPR has a launcher. And I'm guessing every time you go to play The Witcher, you see that there's this brand new game called Cyberpunk available, right?
You click play and then
Yeah.
it pops up the launcher, then you click play again.
Yes, and so they basically get to show you an ad every time that you want to play a game, right? You see all their other games. Even smaller companies like our local Stardock have their own launcher. If you want to play one of their games, you're going to learn about all the rest. That is what Valve had in the early days, okay? Except their small internal game launcher eventually started accepting other games titles, right? Other studios' titles, and it started to explode, okay? At first, it was just very, very tough to get your game onto Valve's launcher. You had to know people at Valve. You had to get their permission explicitly to put your game on to Steam. But if you did get your game onto Steam, you were going to do extremely well. They were going to put your game in front of a lot of people, and you would pay a tax for the privilege. You want to learn more about this, you take EECS 440. But what was the tax? Does anyone know? What's the tax today? What do you have to pay if you make a sale on Steam?
I think $100.
Well, to upload your game, you need to pay a $100 initial fee, yes. But, yeah. 5%? No, that would be a dream. Gabe N. would be the savior of the industry if he did this. But he has not done this, yes. 30%, yes. So every time you make a sale, you give 30% to Valve. And then remember, you've got other taxes to pay, local, state, and federal taxes. And so I think studios come out with like 30% of their game's value at the end of the day or something like that. It's a little bit depressing. Anyway, so this Half-Life 2 is one of the main reasons you installed Steam, and a lot of people were very salty about it. And a couple decades later, Valve is one of the most impactful companies around, and they've got tons of power and resources as a result of this. Whenever you find a company trying to use one thing to get you to do another thing, that's kind of what they're trying to create. They're trying to follow that kind of Valve Corporation Steam blueprint because it worked so well for them. In many cases, it doesn't work well, though. Ask EA about Origin. Anyway, physics was a huge, huge, huge deal in the Source engine. Source engine was an early 2000s game engine, but it had just tremendous potential for physical simulation. So in Half-Life 2, there's a puzzle where you need to use a bunch of bricks to weigh down a board so you can actually jump off of it onto this ledge, okay? That is all enabled, that kind of game design is enabled by the fact that this game is a very physics-oriented game, and most objects have really solid collisions and good physical simulation. This kind of thing today, and you just saw an exploit, right, that Valve I don't think has ever patched. You see a lot of game engines that have nice, easy-to-use physics today, right, with rigid bodies in Unity or the static mesh component in Unreal. But back in this era, very, very rare for you to get high-quality physical simulation. And this game ran on fairly low-end devices, too. And yet we have great water, we have a beautiful world, we've got physics, interactions, good gunplay, nice AI, and cutscenes and character animation. This engine really did have it all, okay? And you're all giggling while I watch and show off exploits. Portal was a big game that was on Steam, okay, that used this engine. And Counter-Strike TF2, did you know Titanfall, right? EA's very exciting first-person shooter used a heavily modified version of the Source engine and did very, very well, okay? It is a widely available engine. It has a big kind of wiki full of information and tools that you can download and some tutorials and guidance on how to do things in the engine. Okay, but despite all this, how many games do you know of? How many university programs are teaching Source Engine compared to Unity or Unreal or even Godot? Okay, why didn't Source Engine become the Unity that we know of today? Why didn't it become Unreal? What's the problem? Any thoughts or speculation? It's not something I've thought about much myself. Yes?
All these games are first-person shooters.
Yeah, that might be a part of it. So Valve is very known for first-person games, but there's a huge market of people who want to make other things, third-person games, platformers, right? 2D games, stuff like that. And so for a company that was known for being kind of small, Valve, perhaps they didn't have enough documentation, okay? Perhaps they were a little bit too late. Their licensing might have been off. Or, like Evan just said, perhaps the engine was just too specialized to that first-person style of game that Valve liked to make. Now, Dota 2 is a game, one of the few that is not first-person that uses the Source engine. So Valve did eventually get to this, right, making kind of a League of Legends style game. Or I think some people would say League of Legends is a Dota style game. Dota came first. Yeah. Second mover advantage, I guess. Dota is not nearly as possible as successful as League, from what I understand, but people do still love Dota. But I think maybe this came a little bit too late. Okay, by the time Dota 2 was under development, Unity and Unreal had taken a lot of the market and kind of bulldozed things a bit. This is largely a PC-only engine, but there have been some minor ports to platforms like Xbox 360, a famous PS3 port that was very bad and well known for being very bad. They had something of a miracle port to the PlayStation 2, which was regarded as a very weak console in its generation compared to the GameCube or the Xbox. And so you can look up YouTube videos if you want to. But in any case, I want to show you a video real quick. This is kind of what the engine's main world design tool looked like. It's called the Hammer Editor. I remember playing around with this and not being able to make heads or tails of it as a kid, right, in like high school. But when I look at most of this here, like this is just visual noise. You can't barely do anything with this. This is very useful up here, though. They used a scripting language called Squirrel. It was kind of Lua-like. And I want to point out and show you a really fun clip. So as you work on this engine, as you do your other courses, you're getting probably a better feel for what it means for something to be called spaghetti code. Okay? In 494, we really focus on what it means. In general, you want to avoid hard coupling. You want to avoid dependencies that link two systems together and make things very hard to manipulate or change. Okay? And so I'm going to show you this code right here. This code, this video. This is not spaghetti code. This is risotto code. When you use a visual programming language, like you're about to see, it's going to be a little bit. You're going to discover that there's nothing inherent to making something spaghetti. Just because you have a textual programming language doesn't mean that that's the only place spaghetti can show up. Okay, let's take a look.
Coding in a language to script all the level logic. On AI and Half-Life is this beautiful example of something seeming a lot more complicated than actually. Back when you're working on Half-Life 1 or Half-Life 2 era stuff, you're not really coding in a language. To script all the level logic, you have to use entities. And these entities are like icons or like visual things inside the world. So when you're scripting, okay, first we're going to walk in here, and then that'll trigger the door will close, and then you have to trigger this sound, trigger that sound. Each of those is like an independent thing that like the level designer had to make, and then manually like connect to this other thing. So what happens is that instead of getting like spaghetti code, you have like paella code or like risotto code, where it's not a long line of all these words in this programming language. It's literally just visual noise of 100 icons. You're trying to remember which of those icons you attach that logic to. Yeah, you have to like create the trigger and convert that into a brush entity and then add all the information attached to it. Or there's some stuff where you're not necessarily attaching the scripting to like wall or a door or something, you're attaching the scripting to just this random point in space as a hack.
Right. So you can get a sense that even if you are avoiding these scripting, these textual languages, you're still going to run into the complexities that come from dealing with complex logic. So anyway, to every one of your friends who says that Unreal Engine blueprints are not programming, it's blueprints, right? They're definitely lying, okay? It is definitely programming, and a lot of the same pitfalls that appear in normal programming will also appear when you go to program in a kind of visual scripting language, whether that's GameMaker or MIT Scratch or Unreal Blueprints or whatever you want, okay? All right, anyway, so let's go ahead and get into the thick of it here. Your assignment was due today. This is assignment 5 from ASCII to 2D. I'm really curious on how it went, in particular because of how much it changed and how much the evaluation changed this week. How did it go? Did you find it really difficult to get things linking? You have the 2 additional videos. I added runtime path footage to the end of the back OSX video halfway through the week. So maybe you missed that if you got wrecked by that. Yeah.
So I started on Mac. I started on Mac and it went relatively smoothly.
Okay.
And then I went to Linux, which I had to build the source code directly for the...
to run it locally?
Yeah, to run it locally.
Yeah.
Which was fine. But then on Windows, that was also okay, but then I didn't have like the int argc whatever.
Yeah. How much time did you lose to that?
I gave up, and then I went back to my Mac, and then I went back after someone had that same error.
Yeah.
There, and I was like, there you go. But I was not, I lost like an hour.
Yeah. You lost an hour? Okay.
And I was like, I'll come back to it later.
So the last night I did a push, and now the autograder will look at your main function and tell you if it's not good enough to build on Windows. So now it'll literally be a warning, and it will tell you what signature to use. In general, that's how iteration works in a lot of my courses. We kind of wait for students to get wrecked by something. I'm so sorry. I really appreciate my guinea pigs. I'll take good care of you, I promise. But we wait for students to get wrecked by something, and especially if multiple students get wrecked by the same thing, that's a huge, glaring red light that we got to go in and automate that away or something. You can't just put a warning in the assignment spec, because I'm pretty sure that it's there right now. Right? You can't just make the manual longer, because as everyone who's taken 494 knows, no one reads the manual, okay? Like, they might go to it, if you're lucky, when they run into problems, but they might not look at the right place, and things can start to get very nasty. So as the course goes on, it actually gets significantly easier for every single year of students that takes it. And if it gets too much easier, what we do is we slip in more content so that you can actually learn more with roughly the same amount of effort. We don't want things to be too hard, but if we make it too blank and too easy, then you won't learn as much as you probably want to learn. So it's kind of an interesting thing. But in any case, if you notice that a bunch of people are getting wrecked by the same thing, like, that's worth a DM or an @ okay? At me, feel free to do it, or send me an email or something with an autograder recommendation. Okay. Yeah, off by 1 pixel errors. I know that this made things a lot easier, because as soon as I implemented it, your scores started going like exponential, and people were able to move very quickly. A quick fun story time from last year. In the debut semester a year ago, the autograder could not distinguish between timeouts and dynamic linking errors on Windows. What does this look like? Well, if you build your program and it builds okay statically, and then you go to run it, but it doesn't have access to the DLLs it needs, well, it'll run, but on Windows, it will immediately crash because it doesn't have the DLL, right? This is a dynamic linking issue. Dynamic because it happens when you are running the program. It happens at runtime. Static linking happens when you're in Visual Studio, you're building, okay? Anyway, what would happen is our students would get what looked like a timeout error, which suggests that your code is not performant enough. But this was happening in the earliest test cases, where it doesn't make sense, right? You can run things horribly slowly, and you're still going to pass these. Well, eventually I take one of the students up to the autograder room, right, literally my office, and we turn on the monitor, and we see this right here, right? What happened was that if you have a dynamic linking issue on Windows, it will actually put up a chunk of UI in this nasty little panel, and this will hang the program. Okay, it will hang the program and make it look like it's not running fast enough. It won't give any special failure error code or anything like that. And this was a huge problem. It turns out in Windows, you can write some operating system calls. I can't remember if your helper does this. I think the autograder does it before it runs your code now. And it will tell it, whatever you do, don't do this, okay? Operating system, please do not tell me if I have a dynamic linking issue with a pop-up. And that changed it to now emitting a specific error message, which we can catch on the autograder and tell you probably have a dynamic linking issue, okay? In any case, a ton of students burned a lot of time because they didn't understand what was wrong with their program. Now you all kind of do for the most part, or you have a better idea. You're able to move much faster. Your morale and energy isn't sapped nearly as fast. This is just how things tend to iterate, okay? And it allows us to fit more things in the course. So, by the way, most of the fixes to something like this, and this is a course design thing, most of the fixes become really obvious if you're just paying attention. And when you end up at a corporation or a research laboratory, when you end up in a similar position to me, right? Just kind of keep your eyes and ears open, right? Pay attention, be in the thick of it, especially in the early going, and you'll figure out what's burning all the time, all right? That's why the feedback forums give you extra credit. I want you to tell me what's annoying about these assignments so that I can fix them, okay? So that fewer Piazza posts, fewer losses of time, fewer questions in office hours, and that gives me back time to create the next course, okay? All right, okay, blah, 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 blah. Assignment 6 has released Continuous Worlds, okay? Last semester, this was the most difficult assignment in the entire course. I don't think that's going to be true this semester because of the changes we've made with similarity scores. But we will be paying close attention to how things go. And if we need to make changes or tweaks, you can expect that to happen in this first week especially, okay? We might have to, for instance, kill some test cases if they're just not accomplishing what we want them to. So please, though, we're going to talk about this. Please get started as soon as you can on this assignment. Get a feel for it, okay? You don't have to start immediately, right? Take a few days off. I recommend doing that. But don't let it get to that final week and you haven't started, okay? There is a reason you've got 2 weeks. I want to remind you kind of how things work with your helper and all of your code, okay? So let's go to the Homework 5 solution again. And we're going to go in. And I think you'll be able to, So I'm going to open up this project. What you're going to see here is that every test case you download comes with a few things, all right? Every test case you download from the autograder comes with a resources folder, and it also comes with an SDL_user_input.txt. If you look into what is actually inside of these, you'll find this kind of weird sequence of numbers, okay? What's happening here is that the first number is your frame number, okay? The second number, I believe, is what is the event? So I think 768 is the press down event. So the SDL event comes through, and you've pressed it down. 769 is release, and then the final part is like an argument. So 79 means a certain key. I think it means like the right arrow key, maybe. This file right here, how does it work? Well, if you go into your helper, okay, if you look through your helper.h and really examine what's happening in here, this helper is going to load, it's going to look for that file, and if it finds it, it's going to enter ghost playback mode, okay? What's going to happen here is it reads this text file, and it actually generates these events. It puts it into the queue so that your code can pull it out of the queue. As a result, this creates a ghost player. This is the way that on the autograder, we can have a ghost player play through your engine and have the game do a bunch of different things to test out your features. I'm not there playing your game, okay? And so this is how we kind of fake that and make it happen. There are some features you can turn on or off in this engine if you want to. If you go to this recording mode, Boolean, and you turn it to true, what will happen is while you are playing the game, it will be generating a file like that for you, okay? So that you can then replay your own inputs if you want, and you can examine things and how it changes over time. What else? Autograder mode. If you ever have an issue, a common issue, actually, is, hey, it works locally, but it fails on the autograder, okay? That is a very, very common thing to see, okay? And let me run this really quickly and see what happens. What test case do I have going right here? Okay, this is a simple test case where my character, Spot, runs back and forth, and there's an NPC to kind of help us tell how we're moving, okay? What I'm going to do is I'm going to switch this autograder mode to true, okay, and save it. Now, if you look at this folder, okay, you'll look, there's no folder in here called frames at all. But after I run this, there's going to be one. Okay, I run. Okay, running, recompiling, because everything uses helper, and so we have to, unfortunately, recompile basically everything. Okay, did you see that? See that beautiful gameplay? On the autograder, we actually don't render your visuals to the screen. We also don't play any audio, okay? Why? It speeds us up, okay? It speeds everything up quite a bit. It also, how many of you know Professor Kloosterman? Right, John Kloosterman, fantastic professor. I believe he usually teaches 280 or 183.
45. Right?
45, yes, 45 a lot as well, with Professor Diorio. I get a fun email from him last year around this time. And the email says, Austin, your autograders are like making noises. They're chirping and sometimes yelling at me, okay? And I realize that, oops, right, I've forgotten to turn the audio down on my autograders. But also, if you think about it, we shouldn't really be playing music on the autograders at all. The autograders don't care about the music. They don't have ears. And so we turn them off when we detect we're on the autograder. Now notice right here that a frames folder has been generated. If you go into it, you'll find that, oh my goodness, there's one frame output to disk, okay, for every frame of the game that we played. And you can look in here, and you can actually see all these different frames. Here's one where we get really close to the NPC. Here's one where we walk away from him, okay? If your local version of your engine, you run it locally, and hey, it works on my engine, chances are it doesn't, but you're not quite noticing that it doesn't. You need to go in and verify in autograder mode that it functions, it runs, it has the right amount of frames, and those frames contain the right things, okay? So this is one additional way that you can kind of debug the situation when things are a bit different locally than you want them to be, okay? And I'm going to discard these changes real quick. Isn't that nice? GitHub for desktop is so very nice. In any case, make use of these tools as much as you can, and your life will get much easier, okay? All right, blah, blah, blah. Oh, yes, a quick trivia. Does anyone know why all of our test cases are outputting frames in BMP format and in really low resolution, like an artificially low? No one's playing at the low resolution today. Yes?
Less to do image processing on.
Yeah, and you can just read it here, of course, right? So we had a huge issue. Initially, we had big images for each frame, which was really cool, right? Super cool to see. But and we were outputting PNG images, which are much more common, right? What we discovered was that PNGs are extremely slow to create, right? To do the compression for the frame and then to output it to disk is a huge problem. PNGs are very small and space efficient, but compressing them down to that size is a huge slowdown. And so I discovered a year ago when I was doing the autograder stuff, developing it, that if we were outputting PNGs, I could run at like 10 FPS tops when nothing was happening. But if we output BMPs, which are much simpler format, much faster to create, but much bigger on disk, we could move at lightning speed. And so we changed to that. We could also decrease the resolution to something that is playable but small. and that was extremely helpful too in speeding up the autograder. One interesting thing here is that BMPs are lossless. They are huge. They don't do any compression. And so our big issue in the autograders isn't performance in terms of speed, but how much disk space do we have? Later on in the course, you will have test cases that are epic, like 30 seconds long, okay? And that is like getting close to something like a gigabyte, okay, of footage and storage that we need per student, okay? And so it really is a bit scary. Okay, blah, 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 blah. Okay, blah, 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 blah. All right. The last thing that I'll show you before we get into it is I found a really great story the other day on a topic that might be near and dear to you, especially if you grew up playing on the PlayStation 2. I'm not sure how many more of us are left who grew up on the PlayStation 2 coming through this course. What kind of games did you all grow up playing? What were your childhood games? And I'll tell you right away, my first game ever was Crash Bandicoot for the PlayStation 1. Okay?
Lego Star Wars and Kingdom Hearts.
Wow, for PS2.
Yes.
Okay, so we are still PS2 generation. This might be the last couple generations that grew up with the PS2.
Lego Star Wars and Skylanders.
Which, Skylanders?
Yep.
Okay, right. I grew up with Spyro as well, but not in that format.
Lego Star Wars and Pokemon Soul Silver.
Lego Star Wars, just, you know what Lego Star Wars did? I'll never forgive them for this. They took one of my favorite developers, Traveler's Tales. If you are playing a lot of Lego games, you would know them as TT Games. What a rebrand. Ridiculous. Awful. Okay? Imagine taking a cool name like Traveler's Tales. They even had their own mascot character in the logo. And now they're TT Games. Super sterile and corporate. They have been banished to the Lego mines. They've not been allowed to make anything particularly interesting outside of Lego since that first game, for the most part. Yes? DS Lite. Fantastic. Yep, good. Yep.
Old classic Wii Sports on the Wii.
Wii Sports on the Wii. Okay, Wii generation. Very good, very good. Okay. All right. So this might be near and dear to you. If you want to learn how the PlayStation 2's backward compatibility was created, and it was really only a small handful of like 2 people that worked on it and saw it all the way through. It's a pretty harrowing tale, and you can read through it if you want to. Okay. Another amazing thing here is that the person who did that is still alive, is still in the midst of their career. Okay, this is that young of an industry. Never forget that. The legends of this industry are still around. You can still email them if you want to learn more. This will not be the case forever. Okay, so take advantage of this if you can get up the courage to do so. All right, I want to talk about homework 6, okay? A very timely topic, but I'll say it is not imperative that you start this immediately today. Usually I have a couple of students, I believe the term is cracked. That's the term I heard of last year for the first time ever. It was like we had students just tearing through our super difficult assignments and said, oh, that student is cracked. And I would look at their code bases and I would know what they meant. They were just tearing through these things. Very good programmers. So you do not need to start this immediately, but I know that some of you, being cracked, will do so. Okay? So this is an assignment that last year you either loved it or you hated it. Okay? And I'm working hard to try and get it more in the love column for more people. But this is an assignment that is going to make this game that you're making, this game engine, feel a little bit more modern than it previously did. Okay? This is also an assignment that's going to put a lot more pressure on your performance chops, okay, than this previous week, all right? I want to talk briefly about grids and why they are fantastic. If any of you are playing Civilization 7, okay, then you are in that grid mindset once more, okay? With grids, right, we have quite a few benefits. Right? Whether we're making like Flash, a simple game like this, or we're making something like Civilization 5. Grids provide us an enormous amount of visual clarity, okay, and organization. There's also tends to be more of a focus on the design of the game and its structure overall. You can get a feel for why most game designers get their start playing tons of board games, okay? board games remove a lot of the technology, and they put an enormous amount of pressure on your game's design and its structure and the resources and decisions it can provide you. Okay? If you look at something like chess, this is a good example of all of this. So the game of chess is extremely visually clear. Once you know what the various pieces are, they're very distinct, and where those pieces are on the board and where they can move to is also extremely visually readable as well. It's not too noisy, okay? It also, the game of chess doesn't have any action gameplay, okay? It doesn't have any dramatic narrative story to hook you. It really has to live and die by its game design, okay? And it really has for many, 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 many decades, okay? It is also very computationally convenient and efficient to have grids, okay? Currently, how do you check collision? How did you check collision on homework 3, 4, and 5?
Are they in an adjacent square or are they in the same square?
Yeah, and how do you do this? Like, what do you have to do? What mathematically do you have to do to decide if someone is colliding with you? Yeah.
It's look at the target square that you were going to
Yeah.
move to. Is something already on that square? Is thing on that square blocking?
Yeah, exactly, right? It is not possible for a character to be on a tile but slightly on another tile, right? That's simply not a thing that can happen, okay? And so you can do collision detection really, really easily and in O of one time without a whole lot of help from accelerating data structures. You have just a couple, and you can do it extremely fast, okay? Collision's super fast, rendering is also ultra fast as well, okay? But grids, they have a lot of problems as well, okay? The biggest among them is that they're simply not very realistic, okay? When we move around in our world, we don't really move around in a grid-based fashion, okay? In most cases. And in the cases where we do have a grid-like situation, i.e. parking lots, okay, you still move in a continuous fashion. And sometimes you can, you're accidentally in several grid spaces, okay? And so it's still not a grid, and you can't do easy collision detection as a result. Grids also have a lot less entropy than action games tend to have, continuous world games tend to have. What on earth do I mean by this? Compare the game of chess to the game of Grand Theft Auto 5, okay? In Grand Theft Auto 5, you have a lot of things moving around in many different directions. They all have very advanced and interesting physics. It becomes very hard to predict how things will move in Grand Theft Auto 5, and so you're kind of amazed and at awe just watching things fly around. There are YouTube videos where the only content in the video is to go and see how many explosions we could stack together in Grand Theft Auto 5, and you just watch objects go flying. It's a beautiful display of chaos. That's what I mean by entropy. Things flying everywhere, things falling apart. You don't really get that in grid-based worlds, okay? Yeah, imagine GTA Online, but it's a grid-based game now. Probably not going to work that well, okay? Very boring physics in these grid-based games, okay? And very stiff motion, all right? These cartoony games, I was very flattered, and I shared with my artist, Nastya, who did this art. Someone put in the feedback that they really liked the art and the characters, and that made me very happy, okay? These characters, I actually have games meant for them. They were made originally for other games, but those games never found the gameplay that I really wanted. It was never high quality enough. And so these characters are kind of like on the unemployment line right now, and they're just kind of waiting for jobs from me, odd jobs. And I get them jobs like this on occasion, okay? So I feel kind of bad, but I'm happy that they're finding some appeal here. Maybe I'll make some stickers for them for the course. That'd be kind of fun, okay? Now, imagine that we want to move from this grid-based world, which feels stiff and static, but can still be very fun, good gameplay, to a more interactive, faster-moving world with dynamic collisions. You can no longer really predict where characters are going to be or how they're going to move. It's much harder to detect whether they're colliding or not, okay? This is a much better simulation of how the real world works. This is the kind of gameplay and motion and world, continuous worlds, that lit up the industry in the 80s when Super Mario Bros. Brought these beautiful, seamless, flowing, smooth worlds with smooth movement into the popular kind of market. Okay, and of course, if you look at modern games, this one, Resident Evil 4 Remake, you will find that they have just they're all continuous, right? And so, are we giving up on grids? Well, the answer is no. Okay, this was the previous game that these characters enjoyed. It wasn't all that fun, but I do think it kind of looks kind of cool. I kind of want to play it just looking at it. But this is a continuous game. This game has a continuous world, but the way you interact with that world is grid-based. Okay, so it can be the case that you can gain a lot of value by combining the two. All right, a continuous world that enforces a grid can be a very powerful thing. Okay, it looks great, but you also get a little bit more of that kind of classic style of gameplay. So grid worlds are a subset of continuous worlds. The opposite is not really true. Okay, if you have a continuous world, you can enforce a grid world. But if you have a grid world, it's very hard to get a continuous world out of that. How could you do it, though? Does anyone know? Yeah.
You can make the grid so small that each grid is just one pixel.
Bingo. Absolutely. Okay. Imagine for a second that we made our grid cells ultra small, like the size of an atom, and we said we're going to have a gajillion of these, and now your character can move many grid cells at a time, okay, in a given frame. You've kind of recreated a continuous world, haven't you? Okay. But I would kind of say that in a general sense, continuous worlds are more expressive than a grid world can usually be, okay? And that's what you're going to be moving to, okay? This week is going to be focused on rendering in a continuous world. We'll have cameras that smoothly lurk and follow our character, okay? Not just stuck on them, but smoothly follows the character. We're going to have collisions that you'll have to compute in a much more kind of challenging way. It's not super hard, but we're going to introduce something on Wednesday called AABB. Anyone know what that means? It's a very, very common form of collision that a lot of engines will support. It's called axis-aligned bounding box, okay? It's a fairly fast way to detect collision, but it's not going to be fast enough. You will, during this assignment, have to integrate and come up with some accelerating collision-based data structures, okay? On occasion, some of my students will do a quad tree. In class, I'm going to show you a technique called spatial hashing. That is kind of an extension of the accelerating data structures you did for homework 3, 4, and 5. That's going to dramatically speed up your collision detection, okay? This is a tough 2 weeks, but for kind of different reasons than homework 5. Performance is a much bigger deal on this homework assignment. Some students really like that, right? And enjoy trying to go through their code, think up algorithms that are a bit faster, do less work, right, without compromising correctness, okay? And I really enjoy that stuff. I'm not very good at it, but I think you'll enjoy it too. The integration tests are pretty difficult on this homework, okay? Now, I'm trying to figure out whether they're difficult but fair or whether they're difficult and unfair. And if I determine it's the latter after seeing you all go through it, then I'll probably just axe those test cases, or I'll change them in a way that makes them much more fair. But we're going to see how it goes. You're going to have, hundreds of thousands of actors all at once. So you probably don't want to render them all, okay? When you are doing collision detection, you probably don't want to do an n-squared algorithm where you compare every actor to every other actor. That sounds like a bad time to me, okay? You'll get away with it for the first few test cases. Your collision detection is going to be much trickier, and you're going to have to come up with some ways to accelerate that without getting correctness issues. Now, there are some small mercies here, okay? You have no new dependencies to integrate or to link. So that's really nice. You can just get straight into it and start focusing on your logic that you encode in C++, okay? This is probably going to be pretty satisfying work because your engine really is coming to life, right? At this point, as you work through homework 6, you could, theoretically, make a game, right? How many of you are artists, right? Heck yeah. Super, super cool. Hopefully EECS 298 will make many more people artists. Like you could, if you wanted to, make your own map, create your own intro scene, your own outro cut scene, create a narrative, and then actually make a game if you want to. Send it to one of your friends or your friends and say, hey, like, I got my own game engine, now I have my own game. You are still locked into this genre until 2 weeks from now when we start homework 7. But you could create some pretty cool stuff, okay? Please remember the chain of help, all right? What is the chain of help? What do? You have a problem. You spend a couple minutes solving it. You then ask GPT or your favorite AI assistant. When you ask and get some information, if it works, you make sure you try and understand what's going on, because on the exam, you might need to answer that question yourself without GPT. But then escalate to Discord, very, very popular, or Piazza, okay? Reminder, please do not drop expletives on Discord, okay? The ban hammer has already come down a couple times, and so please do not do that. If you do get banned, come see me after like half a week, and then I'll add you back in, okay? All right, and the next homework is my favorite in the course. I think you're really going to like it. You're going to end up with a very clean and very, very expressive code base. One of the things that homework 6 kind of makes students sad about is that homework 6 is the last time you are going to be writing gameplay logic into your C++ code base, okay? After these 2 weeks, you will definitively not have a game. You will have a game engine, okay, where the user of your engine decides what the game is in all of its glory, okay? This means that this week you'll be writing C++ gameplay logic that, unfortunately, you're going to be ripping out, okay? Now, not all of it, okay, but some chunks of it you're going to be ripping out and you're going to be replacing it with Lua integration, okay? So just be ready for that. Personally, I love to go into a code base and start deleting, right? Because I just assume it's Garbo anyway. And have any of you ever had bed bugs? It's a really nasty infestation that can afflict your home. Basically, they crawl into your bed and they live in your bed. They're almost impossible to get rid of. It's very nasty. You know how to get rid of bed bugs in any home? You burn the home down, right? That's something you can do. And another thing you can do is if you know they're in a bed, and mostly in this bed, you can just simply cut the bed out of your house, throw it away, and the bugs are gone. So that's what I'm talking about in your code base. Homework 6, you finish it, and you've got some nasty bugs hiding in there. You just know they're there. You don't like your code base. Well, guess what? We're going to cut that part out, throw it away. You're going to have a very clean and elegant code base moving forward, okay? Homework 7 is when everyone's code base becomes mwah, okay? And then it just gets even better with homework 8.
Yeah.
On homework 8, you actually start to mix C++ components that are built into your engine and Lua components, which are custom written by your users, okay? And then in homework 9, you're going to do the same thing. Homework 8 introduces the C++ component rigid body, which if you've used Unity, you will know about. And then in homework 9, we introduce the C++ embedded component particle system, which if you've used Unity, you already know about, okay? It's going to be very similar in both cases. Okay, someone had their hands up. Anyone have any comments or questions on all this business? Yes. No, you're good? Okay, yes.
Out of curiosity, how long will we have access to the GitLab repos and their history?
Yeah,
after
it's a good question.
Graduation?
So, in general, we have to be kind of careful. We can't let you publish all of your commits because your commits are valid for homework assignments. If they're available online, some kid can just go grab them, and then our cheat detection will find them and then blow them up, right, at the end of the semester. And so what we usually do is the very last assignment in the course, the postmortem assignment, requires you to take the final commit of your engine and to upload that as the initial commit into a public repo that you own, okay? Because eventually I will delete your GitLab repo. Unfortunately, the history will be deleted as well. That's kind of sad, right? It's kind of cool to have a repository. So take a screenshot, okay, and put it into your actually put it into your new repo as a memories, little memories.png, right? So you can prove it if someone at a company wants to know about, how long did you work on this? But basically, yeah, you can take the final version of your engine in source code, but you cannot take the earlier versions, okay? And that's for basically preventing cheats, okay? Eventually, we could have a bad situation where there's so many engines available for the course out there, and the assignments aren't changing enough every semester to invalidate those, that someone just goes and grabs engines as they like, and then we have to have really difficult situation at the end of the semester for dealing with that, okay? Anyway, yes. Any other questions? Very good question. All right, cool. Very good. You could do what Jacob did, and you can say, you know what? I just want to make my own engine. Jacob said, I like my course engine, but I'm going to make a new engine from scratch, kind of based on that course engine. I'm going to make it much nicer and much faster, and that's what he did. Maybe make it with Python as a scripting language instead of Lua. Okay, cool stuff. Makes sense to me. If we really wanted this to be the create your own Unity course, we would have done C# as the embedded language. That would have been super cool. Super cool. Okay, yes.
Why didn't you use C#?
Integration is way nastier than Lua, from what I could tell. In my experiments, it was like, I got to teach a student all this, and it was just very nasty. Lua is also just a very good intro language for hosting stuff. Integration is not very hard. No. Yes?
What are some really easy languages to integrate?
Really? Languages for what?
Integration.
For integration? Lua. Python. Python is a little bit more annoying, but doable for sure. C# is something that sometimes gets embedded, right? There's some documentation on it. It's not very good. What else has been embedded before?
You could do Java to C++.
I was thinking, doesn't Android do this? Android is written in C++, but apps are Java, right? What else?
Those are just the apps just generally run Java.
Here's an interesting one. So at Sucker Punch, they and Naughty Dog, they were using Lisp, I think. They were using a functional language, right, as their scripting language, which is really, really cool. I do not know much about functional languages. I've never had a strong urge or curiosity to use them. But yeah, pretty interesting. Okay, sometimes JavaScript is also something you'll use, okay? For obvious reasons, there are a lot of people who know JavaScript, so that's not a bad choice. Okay, what I want to do, I think this is next here. What I want to do is I want to talk about the input manager pattern, okay? This is a really powerful pattern. Now, do you remember when we talked about inputs, right? A couple lectures ago, we were talking about SDL and how you can deal with inputs in SDL. You absolutely must do an event queue, okay? Now, this is not optional. If you don't if you don't drain and process that event queue, then it will freeze your entire program, and that's not good. But the event queue way of doing things is not very convenient, usually. It's kind of nasty, all right? What you see here is simply fabulous. I like this GIF a lot. This is how Unity's original input system worked. And if you haven't seen this before, basically you have 3 functions. These functions all are public static. What does that mean? Now, first, it means that the EECS-280 would freak out, okay? But there's a good reason you want these to be public static, okay? What does that mean to be public static? Yeah.
They're completely accessible and they only exist once.
Bingo. They're completely and utterly accessible from any area in your code base, okay? You can call them from any corner of your code base, anytime, any day. There are some coupling issues this creates, okay, that are a bit spooky. But in general, that accessibility you get is worth it. What you see here is that these functions return bools. They're going to give you a true or a false. The get key function is very simple. You provide it the name of a key, like right or left or spacebar. And it simply tells you whether that key is currently down on this frame or not, all right? If it is currently pressed, you get a true. If it is not, you get a false, okay? But there are also these two other functions that are really interesting and really useful, okay? Get key down. What does this mean? Well, it's a variant. It's a variant. It is only true on the first frame that you have pressed something, okay? Only true on the first frame that you've pressed something. Now, if you continue to hold the button, it's false, false, false. But that first frame that you go in and press it, it's true and then false, 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 false. The longer you hold it, it just stays false until you press it again. So why would you care about this distinction? What's the point? Well, imagine this. You have a gameplay mechanic that involves jumping. Spacebar makes you jump. Woohoo! Okay? If I write some logic that uses input.getKey, if input.getKey, parentheses, spacebar, then do the jump, right? Now, what happens if I use this and I just hold the spacebar down? What is Mario going to do? He's going to go, yippee, and he jumps and comes back down. But then when he gets back down, he immediately does what? Goes back up again. Yippee, wee-hee, wahoo, yahoo, right? That is, that's probably not what you want, okay? It's a little bit awkward. The controls are going to be seen as a bit weird, okay? What you want is instead input.getKey down. If the player continues to hold space, you do not want to continuously make Mario jump. You want to wait until the player lifts that key and presses again to go up again, okay? Now, same thing with get key up. There are moments when you want to use this. This function is only true for the one frame in which you release the key, okay? Why would you care about this? Well, have you ever noticed how in certain games, when you jump, if you hold the button down, you go higher, but if you just tap the jump button, you actually go just a little tiny hop. You don't go nearly as high, right? One extremely easy way to implement that logic is to launch Mario upward when get key down is true. So that first moment we press it, we launch Mario, but then the moment the player releases the key, we take Mario's vertical velocity and cut it in half, okay? So this is an easy way to go, I'm going to press and go wee, and then I release and we stop going up, right? Or I can hold it longer and delay this get key up being true, and that will prevent us from going, that will allow us to go much higher, okay? Anyway, all of this is to say that these three functions, these life cycle functions, allow you to detect things that are happening to your keys on your keyboard, okay? And it's ultra easy to use, just incredibly so. A fundamental question of game design, okay? What is our user's intention at this moment? What are they trying to do or will their character to do? This is usually a button press, okay? But these days, it's actually getting quite a bit harder, a little bit spookier to understand what your user wants, all right? Apple is doing a lot of work to try and figure out, when you put your hand out like this, you see this hand right here? What is this hand trying to do? Is it trying to grab something, or is it trying to point? It sort of looks like a point. My index finger is kind of a little bit more prominent than the rest of my fingers, but maybe I'm trying to grab things, but it's not exactly an aggressive grab like this, right? It's more like, what is this guy trying to do? Okay? That's the challenge that input researchers, right, UI and UX researchers are trying to figure out right now. Okay? You can see down here, actually, she's got this little pinch that she's doing, and the technology is detecting this, and there you go. A question, though, is how to gauge inputs. Well, the current way that we know how to do this, the way you probably did it in Homework 5, how many of you have actually made an input manager yourself? You've already done it for Homework 5, okay? Maybe you made like a crusty one, okay? That's fine. But for Homework 6, you're going to want to upgrade that, okay? And you can follow this lecture and logic to do so. Right now, we mainly know how to process inputs via something called the event queue in SDL. It has a lot of events coming through. Sometimes these events are useful input-related events, so something like key down. They come through, and when they come through the pipe and you see them, you can execute some sort of logic. okay? And that's pretty standard. How many of you ended up writing code like this? You've got your little while loop here, okay, to get you that event structure. You check, hey, is it type key down? And then if it is, you check what scan code it is, and you do something. Okay, it's pretty standard. By the way, the autograder was upgraded to help with this as well, because we had some students who were using the non-scan code versions, which is like, that could get you blown up pretty badly on the autograder. Okay, so if you miss this part of the spec, now the autograder will yell at you and tell you that you missed this part of the spec, and you can fix it, save time, and live a great life. Okay. Anyway, there are some downsides to this. Okay. A question: how do you detect if a key was released on this particular frame? That's not something you had to do, but you might have to do it in the future.
You check for a key up event.
A key up event. I do think that's a thing, isn't it?
It is.
Yes,
Whenever
yes.
the key is released, you get a key up
Yep,
event.
yep. So you can do that. How to check? I think there are some other questions that might be kind of tricky, right? So here's a good one. How to check that these events are happening from a different file? Like, let's say that you've got your little event queue going on, but you've got 10 different places in your code base that want to know if the spacebar was pressed right now. You got your animation system, you've got your collision detection system, you got a projectile spawning system over here, you got a sound effect system over here, you want to play a sound, wahoo, right when you jump. What could you do? You got this one event object, and you want the entire code base to know that some inputs happened, okay?
One thing you can do, which is not an input manager, is use callback functions.
Sure.
So each
Yep.
thing, it makes a function, it then passes in a function pointer
Yeah.
to this area,
Yep.
and then it says, oh, I got a key down event.
Yep.
Let me run all
Run
of
that.
these function pointers.
Yep.
Everything else is given me of what to do when there's a key
Yeah,
down.
later in the course, we'll introduce the event bus pattern, and that's another way of kind of doing that, right? You register for a particular type of event, and a function that you own gets called when that comes through the pipe. But this is, it's a little bit annoying, okay? You have to find a way to either set up a callback system, or you have to take this object, this E object, and you somehow have to kind of send it around to the many different parts of your code base. You could make it a global so that people can kind of check it, okay? But that's a little bit nasty. Our objective here is we want to respond to a button press. So which of these two APIs would you prefer? You can write all of this code, okay, to get your button press. Or how about this? Input.getKey, and then you just say the name of the key you want. I like this bottom one a lot better, and this is the one that I think that you'll want to and benefit from setting up, all right? Especially when you get to your homework 7, where you must get this working, because this is this is C++ code, but you'll need to get this working in Lua code, okay? For your users, okay? So we can call this at the bottom as much as we like. It's a very simple API to use, easy to understand. This is the input queue approach, and down here is the input manager approach, okay? We can use an input queue to implement an input manager. And I'm going to show you how to do that in the next 20 minutes. So let's design an API first. We're going to be inspired by that Unity API for input that I showed you earlier. We can create a class. Let's call it input, okay, capital I. We got public and private data, okay? What might our callers want to know? Well, they probably want to know if a key is currently down, all right? They probably want to know if a key was pressed to this frame and if a key was released to this frame. And so we're going to have 3 functions in C++ that are going to allow us to do this, all right? Instead of passing in a string, though, we're actually going to pass in a SDL scan code, okay? This should actually help prevent typos from blowing us up. But we're going to make it static, okay, bool, so that it returns our stuff, okay? It's going to be public static, so it's easy to call from anywhere. We're going to have a get key down function, and we're going to have a get key up function. Okay? And taken all together, we have our public interface right here in our C++ input class. And you are very welcome to use all of this, by the way, if you want to. Okay? We are basically just recreating Unity's input approach. All right? By the way, when I was making the engine a year ago, I always got a hit of dopamine every time I went oh, Unity, this is how they did it, right? And I just went and implemented a chunk of Unity, just like that. And I thought to myself, dang, could I work at Unity? And then I would say, nah, teaching is way cooler than software dev. I'm sorry to all of you, but that's how I feel. Yes?
Do you know, does Unity use SDL or do they have their own built-in?
I don't think they use SDL. At least I've never seen it. Actually, wait a second. I think we might have looked that up in the Unity credits or something and found SDL was in the credits.
It's
How much time do we have?
Not SDL for rendering.
Yeah, probably for just windowing or something.
Maybe for input and audio.
Yeah, that's what I was thinking as well. That's kind of what Valve does. I just want to open up the help. Okay, Flappy Bird toast. You're getting to see some 494 stuff again. We're back to Flappy Bird. Okay, anyway, while we wait for that to open, okay, we're basically recreating that Unity input UI, all right? And hopefully this feels really comfy when you do so, okay? Like an old friend you're seeing once again. Anyway, why do we make it static? Again, what does static actually mean? What is its most common meaning?
It's only defined once.
Yeah, kind of, right? So when you mark something as static, you're kind of saying, I want to associate this function or this variable with the class itself, not an instance variable, okay? So you can create 1,000 instances of this input manager, but if this is marked static, there's only going to be one copy of this function. It's associated with the class itself, so you don't need any instances to exist in order to call it. Makes it super useful, all right? Very, very useful, okay? Super easy access, this means. It's not just static, it's public static. So there you go. Any of this sound familiar, right? Yeah, it's Unity, okay? So how are we going to implement all of this? What's the play? How do we implement this? Well, here's something you can do that's kind of elegant, and I think you'll enjoy it when you implement it yourself, okay? Our mission here is that we're going to want to track these key codes. These scan codes, each scan code that exists, represents a different key on our keyboard that could be pressed up or down, or could have just went up or just went down. Okay? And so, how can we track the state of a ton of key codes? We don't even know how many there are, but they're going to come through that event queue. They're going to be of type SDL scan code. Is there a particular data structure you might be thinking about here? Somehow, we want to go from any particular scan code to a state for that scan code. Yes?
Unordered map.
A map, yeah, and an unordered one, because we don't exactly need any ordering, do we, right? We don't get a whole lot of value from that ordering, so we speed things up by going unordered. The map is a great idea, because as these key codes come in, we can simply put them into our map as keys, and the value that those keys are connected to is going to be the state, okay? The state that the key is in. We'll create an enum in just a second to track that stuff. Here's a quick note on the life cycle of a key, okay? We got the key up life cycle. What does this mean? The key is just up. We haven't pressed it in, okay? It just hands off, all right? This is the key's normal resting default state. Default state. So that's good to keep in mind, all right? This is where we kind of enter into the life cycle. Now, if an event comes in that is a key down event, and that particular scan code is there, okay? Well, our key up becomes what? Yes?
I want to just say key, because it's when you get key. And
Well, yeah.
Key down.
Or probably key down,
Key down.
right?
Yeah.
But wait a second. is key down good enough? Because remember, we have functions where we want to check easily whether the key was just put down or whether it's been down for a while, right? So what else could we do? Any ideas? Key down is almost there, but here's what we're going to do. We're going to have another state called just key down, or key just down. At the end of every frame, every key just down state will transition again, because it's now the next frame and it is now a key down, okay? A normal key down, right? So you'll need to run some logic at the very end of the frame to basically look at everything that is just key down and put it to normal key down, okay? Now, if you are in a key down state and you do SDL key up, that event comes through, the player has released the key. That means we should go to key just up state. And at the end of the frame, we can go to key up, all right? And this is our life cycle. Now, I think it's actually technically possible for key just down to go straight over to key just up, okay? And for key just up to go straight to key just down if those events come in. I did not put that in the diagram though, but that's something you might want to look at if you're having any bugs, okay? In any case, here's our situation. We've created a nice little enum here, okay, input state. And these are the 4 states that we have available to us. If I recall, at runtime, when you actually go to run your program, the compiler does its thing and actually turns these enums into integers, I think. And so this is just some syntactic sugar. I remember when Professor Ringenberg introduced that topic, syntactic sugar, in when I took EECS 280, right? It is just the way that we present things to help humans understand the code, but the compiler really doesn't care. To the compiler, these are just going to become some integers, right? Anyway, so we've got these right here, and we also need to keep track of the states of all of our scan codes, okay? And so we introduce this data structure right here. We have a static inline, okay, std unordered map. What kind of map is this? Well, it maps scan codes representing each of our keys to the state of that particular key. And the key can be in any of those 4 states, okay? We call this keyboard states, and makes a lot of sense, right? Now, a question for you. You know what static means, okay? We're not going to have 1,000 instances of this dictionary. That would be really messed up. We're not going to have 0. That would also mess us up. We're always going to have exactly 1, all right? That's exactly what we need. What is this inline doing? You don't have to have this. I use it a lot. You know why? Because I'm lazy, okay? Ultra lazy, yeah.
Essentially, C++ has this concept where any static variables you make in a class in a header file, you're supposed to put, that's just a declaration. You then need to go to a source file and make the definition where you actually call a constructor and make the keyboard states. Or you could just call it inline and do everything right there.
Yeah, this is, I think someone said this was introduced in C++ 17.
Yes.
This seems like the kind of thing where, okay, everyone's getting really salty about writing all this definition-related code, when really, if someone writes something like this, it's really clear what they want, okay? The compiler should know what they want right away. So you can add inline here, and at this point, the C++ language kind of starts to work like any other language, like C#, okay? You only have to declare this variable once, and it's also assumed to be defined. If you do not have this inline function, you're going to get a weird compiler error. You might get an undefined symbols error, okay, linking issue. And that's because this, without inline, is just treated as a declaration. It is not treated as a definition. So you have to go into your C++ file, and you have to add basically the same darn thing, just copy and paste it in, and then it will work, okay? What a pain. So anyway, inline is what that does. Okay, inline, you can think of it as saying, hey, this is a declaration, but I also want the definition here, please. Thank you. And that's what will happen. Okay? Okay, so all keys here are going to begin in the key up state, right? Because no one's pressing anything down. You can make that assumption. No test case is going to try and break that for you. Okay? All keys are going to begin in the key up state. Now we need to do some work here. So we're going to have an init function, initialize function, and that function, is going to go through. It's going to go through all scan codes that exist, right? It's going to do some casting to basically say for every scan code, go into our dictionary and set it to be in that input state up, okay? If this code is a little bit weird to you, it's using the fact that all of our scan codes are just numbers, so we can kind of see this code going through int, okay? Change the int into its corresponding scan code, insert that into the dictionary, and initialize it, okay? You probably want to run this as soon as your program, your software begins, so you don't forget about it. Otherwise, you could run into some issues where a key just doesn't exist at all. You could probably resolve this with a lazy load, where you check if the key is currently in the dictionary and you add it as it comes through the first time you see it. That seems like it might be slow doing that check constantly every frame. So this is how I choose to do it. You can do it however you want. And as events come in, we have to react to them. So at the beginning of our frame, we need a way to send that event to our input system for processing. Okay? At the end of the frame, we need to be able to run some logic to take all of our just down and just up events and promote them to the up events and down events, right? Question?
If you're preloading everything and it's all just enumerated in the exact size, why not just use a vector instead of a map?
You could probably do that. You could probably load them all into a vector or an array because it's not going to resize, right? You could do that, yeah. I like maps. I like their API. I like their syntax. But you can use an array if you want to. Okay, so static void, process event, okay? These are the two functions we're going to have. Process event will get called at the beginning of every frame to process events as they come through. And late update is going to get called at the very end of our frame so that our input manager can clean some things up as we transition to the next frame, okay? And you can see in process event, we're just feeding that event through. Why is it constant here? It's a reference, okay? Because we want to be fast. We don't want to be copying that object all the time. Why is it constant? What's the point of that? If you get asked this on an interview, how toast are you? Okay? I would ask this on an interview, for sure. For sure.
So you don't accidentally change it?
Yeah, exactly. This input manager wants to know about events that are filtering through our program, but the input manager should not be altering them, okay? Do not touch, okay? This is read only, all right? And if you design your API in this way, then the compiler will tell you if you are accidentally altering that object, okay? And you can fix it there instead of introducing a subtle bug into your program. Yes?
When you define a function, can't you like do the function name and then like the brackets with the stuff in it and then say const after and then do the bracket? Isn't that a thing?
I think that's a bit different.
Yeah,
is
I
it?
was gonna ask what that was.
Yeah, so okay, yes. So I think it's this. I don't use it a ton. But here you see that const is applying to a parameter coming in to the function. So this function will be fine so long as it doesn't alter E. However, I think that if you see const outside here, what it's saying is that this function will not alter the instance it is a part of. Now, it wouldn't make any sense here because static is not part of any instance. There is no object to alter. But if this were not static, this were an instance function, an object function, then seeing constant on the end here would be your way of saying, hey, this function doesn't alter the object or its state at all, okay? I think that's sometimes called like a pure function. Anyway, yeah, it's a good question though. It's good trivia for interviews. Okay, so anyway, in your engine's main update loop, you might have that classic kind of helper pull events loop. And as it grabs all those events coming down the pipe, we feed those events into our input manager right at the beginning, right there, before we do anything else, okay? That allows the input manager to see that event and do the changes it needs to, okay? There are better ways to do this, but this is fine, okay? In the process event function, we got this object, this event coming through. We check if it is actually SDL key down or SDL key up. Those are the two that our input manager are going to care about. And we use that type, okay, the scan code, to index into our dictionary, and then to set it to just became down if we're in the SDL key down, okay? If it's a key up, we go in, and for that scan code in our dictionary, we set state to the fact that it just became up. We just released it, okay? And there you go. You can see here we're also doing some other stuff. So we have these little vectors. We're pushing this scan code into the just became down scan codes vector. And down here, we're pushing the scan code into the just became up scan codes vector. Why are we doing this? Well, we're doing this so that we don't have to traverse every single scan code to reset them at the end of the frame, okay? So this is optional, but I wondered if this might speed me up, so I did it, okay? This is the late update function. This is something that you call at the very end of the entire frame, okay? What we're going to do here is we're going to go through all of those key codes that just became down, and we're going to then fix them up. We're going to set them to input state down, okay? Because the frame has passed, okay? Now the player is holding that key for multiple frames, and we don't have that just value anymore. We're now just straight down, okay? And the other one just became up scan codes. We go through it, and we set them and fix them up, and then we're done. We clear both of those data structures. I should do some testing to decide if these are really speeding us up very much. I think it depends on how many key codes there are. Because if you want to check like 50 key codes, just quickly going through an array and not dealing with dynamic memory on the heap, probably faster. But if there's like 1,000 scan codes, maybe not. So it's hard to say. This is why you have to profile these things. You test them out. But I don't think I did it because I was probably running late to finish the assignment. Last year was a crazy year. That was like, I think I said this before, but at least 4 nights a week, I was like up to 3 a.m. or something. Then wake up, a few of them were like 4 or 5 a.m. And I have to wake up at 8 a.m., so it's 3 hours. That was rough. Okay. Anyway, as the next frame arrives, we're updating our just keys to become its just normal state, okay? And it works, okay? This is the key life cycle, and it works really, really well. The interface is super nice and luxurious, okay? If you ask yourself, well, how do I implement these functions now? The answer should be pretty easy. You look up in the dictionary what the current state of that particular scan code is. You have a dictionary that's tracking all of this, right? And you return true or false based on what you find in the dictionary. One very common error is you'll be doing a check for get key down, and you'll check whether the key is down in its down state, but you'll forget to check whether it's in the just down state, okay? And so that's a very common error that you can make when you're implementing this, but I will leave it up to you to write that code, okay? Not going to be hard at all, just a couple lines per function for these 3 functions, okay? Does anyone have any questions on this input manager? Again, I'll tell you, like, one of the most satisfying things I made in that intro engine, I'm like, wow, I actually feel like I built a part of Unity, right? This amazing engine that's been so important to my life, and I just created a part of it, right? That's going to be you, okay? I hope you really enjoy. I hope you're finding this to be satisfying work, this week after week after week work. I know it's not easy, but I hope you enjoy it, okay? I hope you find it satisfying at the very least. Yep, sorry, we ended exactly at 6. Maybe I just got on my tangents. My tangents were way too long today, but that's going to happen from time to time. Last thing I'm going to do with you is I'm going to go into Unity's Help menu, go to About Unity. Can I find the credits? Where do I look up the Unity credits? License type, Help, Scripting, Learn, Check for Updates, Manage License, Software licenses. Here we go. Oh, it's a legal.txt. Nice. And we're going to search for it. SDL. Would you look at that? Would you look at that? These are a bunch of SDL includes. Bingo. Sam Lantinga. Okay. How about that? Well, imagine that you're going for an interview at a company and you say, oh, you're using Unity. let me just open up Unity for a second, go to the licenses, and oh, is that my software they're using? You've been using my software? You should hire me. Okay? Imagine what other kind of software I could build for you besides all the software you've been using to do all of your stuff, right? That's got to be kind of a power play in any sort of interview you go into. So I imagine Sam's not too worried about job security at the moment, though you never know, okay? It is kind of rough out there at the moment. So, all right, everyone, I'm going to go ahead and conclude the lecture, and I'll be walking around for the next 2 hours straight. Please let me know if you have any questions you want me to help you with, okay? And we'll try and get you going. All right, everyone on Twitch and YouTube, take care. Thank you for watching, and I'll see you later, okay? Bye-bye.